Hello students, welcome to the class of digital signal processing. This is our third lecture on inverse Z transform, and today we are going to discuss partial fraction method of finding the inverse Z transform. So partial fraction method. There will be two types of questions basically. I will be doing both the questions, but maybe in two different lectures. So let's get started first. The first question is find the inverse Z transform for. I'll just write it in short. Find inverse Z transform for x of z is equal to half z to the power minus 1 divided by 1 minus half z to the power minus 1 into 1 minus 1 by 4 z to the power minus 1. And the ROC given for this xz is, so xz always comes with a ROC. The ROC given for this one is mod z greater than half. Okay, so now we need to find out the xn. So first step, while you're using the partial fraction method, the first step is simplifying xz. Simplifying in the sense that you will bring all the z to the power minus 1 in positive powers of z. So simplifying is the first part. If the simplified form is given, then you don't need to do this method, or sorry, you don't need to do this step. But if it is not given in that format, then you need to do it. So what we need to do over here is x of z is equals to half 1 by 2z, z to the power minus 1 means 1 by 2z divided by 1 minus 1 by 2z. And this side it will be 1 minus 1 by 4z. Now again, when you write it, 1 by 2z divided by 1 by 2z divided by 2z minus 1 by 2z into 4z minus 1 by 4z. Now here I will tell you certain points that has to be kept in mind when you are doing these questions, because otherwise with solving it will become difficult, right? So let's do it. So these are the small techniques that you have to keep in mind. Now I'll just tell you when we are at that point. 1 by 2z divided by 2z minus 1 into 4z minus 1 divided by 8z square. So this will be cancelled for 4 and this will be z. Now this is, how much will this be written? 4z by. So this is 4z divided by 2z minus 1 into 4z minus 1. So while doing the partial fraction method, you have to see that there is no coefficient over here. This is the important thing. There is no coefficient with z. So in order to remove this coefficient, you again need to divide by 2. So divide by 2 and this one divide by 4. So actually you're dividing by 8. So on the top also divide by 8. And in the bottom, you can write it in this manner, divided by 2. And here it is divided by 4. Now the signal that comes here is z by 2 divided by z minus half into z minus 1 by 4. Now this is the standard format of doing it. After that, the second step is that you have to take out xz divided by z, means xz by z. So this whole thing is xz. This whole thing that is coming over here, this one is xz. This z you need to bring it down. So this is xz given to us. We will write xz by z. So we are left over here with half by z minus half into z minus 1 by 4. Now we will turn this. This is the second step. I'll do it in the next step. The second step was what? If you write it in words, finding out or writing it in the form of xz by z. This is your second step. Now when you are writing the third step will be what? Now we move into the actual thing of the partial fraction. That is, you will be converting product from product form to addition form, or you can say sum format, from product form to sum form. What does it mean by telling this? That is that, let us see, x z by z, that will be doing on the right side. This left side will be the same as it is, x z by z. This side, it is, you had half divided by z minus half into z minus 1 by 4. So this will be equal to some value over here, that is, we are taking it as a, divided by z minus half plus b divided by z minus 1 by 4. And now with the partial fraction method, if the all that is, you have to find out the values of a and b. The partial fraction is all directed towards finding this a and b, and then finally you will be putting it, and by inspection you will be writing the transform, inverse Z transform of that. So now the xz by z is given to you. So this full thing, just understand, this full thing is equal to this part. Now, if you want to find out xz by z, what means, if you want to find out a, then you can write it in this manner. You will have to find out a. That means it can be written here as half into z minus half divided by z minus half into z minus 1 by 4 at the value of z is equal to half. Now this and this gets cancelled, and you have over here half by half minus 1 by 4. That will give you minus 1. So the value of a is coming to be minus 1. When you're doing finding out b, then you will have to multiply z minus 1 by 4 and taking out the value of the function at 1 by 4. So z minus 1 by 4 at z is equals to 1 by 4. So now this value will be half divided by 1 by 4 minus half. Okay, so this value is coming out to be 1. Now again we will write the previous thing as it is, means we had written xz by z equals to half z minus half into z minus 1 by 4. This was equal to a by something. So now my a is minus 1 divided by z minus half. And the b is 1 by z minus 1 by 4. Now forget about this portion. We will just work on with xz by z equals to minus 1 by z minus half plus 1 by z minus 1 by 4. Now we can write this as xz is equals to minus z by z minus half. Make this z go on this side, plus z by z minus 1 by 4. Now if you divide both the numerator and denominator in both the terms with z, we will get 1 by 1 minus half z inverse. And here you will get 1 by 1 minus 1 by 4 z inverse. What we have done is we have divided by z in numerator and denominator. Divide by z in numerator and denominator. So now you have to inspect. Now the third step that is coming over here is, or you can say this is the fourth step, that you have to inspect the Z transform. Inspect by popular Z transforms, you can say. So if you have done some questions, then you will be able to, with some basic questions only, you will be able to say that this is the Z transform for what? Which signal? This is the Z transform for half to the power n. Okay. And this one is for 1 by 4 to the power n. Now, this one was a minus and this is a plus. Now we need to see the ROC. The ROC that was given in this case is, ROC is given as mod Z greater than half. Fine. Mod Z greater than half is given as the ROC for us. So when this is a causal sequence. So the causal sequence we will be, so what does that mean is this is your half and the ROC is outside this. So for this, you need to put both the places U of N. And there won't be any changes in the sign or any changes in the signal. You know why we are doing this? Because these are the when we were doing the Z transform, that time we saw these type of signals, or you can say this type of sequence are coming for causal sequences when this is greater than half, right? So we have to take it in this manner, that half raised to the power n. This is your final x of n. We will do one question when we have the disk type of arrangement, or you can say ROC is as disk. Here you saw this. And the one more important thing is that for partial fraction method, here we had all the simple poles. All the simple poles are there. Now, if the pole is of multiplicity 2 or 3, then we need to use the Cauchy residue theorem. Also, here actually we are using the form of Cauchy residue theorem only, but since we are first making it in the form of this A by this denominator and B by this denominator, so we are calling it partial fraction method. Okay. So first thing what you need to do when you have to find out xn by using the partial fraction method is that you need to simplify xz. You have to make all the powers of z positive. After that, you need to find out xz by z. When you are finding out xz by z, then on the right side you are left with some product form. You have to change that product form into some form by taking a coefficient. You can say a by or a or anything. You can take any variable. And then you need to calculate that variable. Calculating that variable, basically we are doing with the help of the residue theorem. But this is the technique you can keep in mind with simple things also, that if you take the LCM over here, this will be multiplied with this part. And then if you're making this equal to this is the thing. If you need to find out A, in that case, you need to make this portion z equal to half, and then you can find it out. Okay. Now, same way you find out B, and then after that, by the method of by just inspecting, not the method, by just inspecting means by, if you have practiced, then Z transform, obviously we are coming to inverse Z transform after practicing Z transform. So from there, just by inspection, you can find out that this is the Z transform of which sequence. Because finally, we are coming to xn is equals to minus half to the power n un. Okay. And if the sequence was, if the ROC of the sequence was given less, in that case, you will have to write, instead of this un, you will be writing u of minus n minus 1. And also the signs will be changing. So it will depend upon how it is, the whole thing is inside, means both half and 1 by 4 is inside, or only half is inside, 1 by 4 is outside. In that way, it depends. Okay, let's go on to the next question now, where we will have a question where the multiplicity is 2. That will be better, I think, so that you can understand with how to find out the partial fraction in case the multiplicity is 2 or more than 1. Fine. So let's go ahead and do this also. So find the inverse Z transform for xz is equal to z into z minus 1, z into z minus 1 divided by z plus 2 whole cube into z plus 1. So now this question we have to do by partial fraction method. Find xn using partial fraction method. And now here you can see the first step need not be done, that is simplifying. There's already in a simplified form that you cannot see any negative powers of z. The second step we will move on, xz by z we will write. Now xz by z is equals to z minus 1 divided by z plus 2 whole cube into z plus 1. So now here this is of multiplicity 3 because this is raised to the power 3. So in this case, when we are taking out by the partial fraction method, we will write it a by z plus 2 plus b by z plus 2 square plus c by z plus 2 cube, and then we will write d by z plus 1. That is a simple pole. Z is equals to minus 1 is a simple pole. So for this function, if I do the pole 0 plot, then we have the poles at minus 2, multiple pole, multiplicity 3, and simple pole minus 1. 0 is at 1. So by the Cauchy residue theorem, you need to find out the value at these points. So we will be doing that in the residue method. So now I will be just talking mathematically about the partial fraction method. The partial fraction method is also somewhat using the you can say the concept of the residue method, but let's do it with the partial fraction method because we have divided the main thing that is why we call it partial fraction is that from the product form, we are converting it into the sum form. This is the product form to the sum form. This is the whole thing is equal to this one. Okay. Now, if I want to find out, now the next step is not if, actually we have to find out, right? So what is the next step is that we need to find out A, B, C, and D. So let's first find out D because that is very simple. We did it, right? So this full thing is equal to this one. And we need to find it out. What we need to find out is D. So first of all, we will need to find out D at z is equal to minus 1 because that will be the point which will make it undefined. So we will remove that point z plus 2 whole cube and this is z plus 1. So we will multiply with z plus 1. Find it out as z is equals to minus 1. So if this gets cancelled, you have minus 1, minus 1, minus 2. And down you have minus 1 plus 2, that is 1. So 1 cube is 1. The value is minus 2. Now let's move on with A. Now see, when you have a pole which is of multiplicity more than 1, means it is not a simple pole, then what we need to do is when you have to calculate A, fine, with A was with z plus 2, A was written as A by z plus 2, right? B was written as B by z plus 2 whole square, right? So this whole thing was equal to how much? If you go over here and see, it was equal to z minus 1 divided by, first what you're going to do is write the full thing z minus 1 divided by z plus 2 cube into z plus 1. Now see, even if 1 z plus 2 is present, minus 2 plus 2 will make it 0. So we need to remove the whole thing. So we are multiplying over here with z plus 2 cube. We are calculating the whole thing at z is equals to minus 2. But there is a catch over here that this value you will put at the end. First, you need to differentiate this. How many times you will be differentiating? So the total multiplicity of this pole is 3. So, and this one, the denominator here was 1. So 3 minus 1. And here also 3 minus 1. And 1 by 3 minus 1. So this is A is equal to 1 by factorial 2 d2z, d2 by dz square of this full thing, z plus 2 cube, and will get cancelled over here. So you are left with z minus 1 divided by z plus 1. So you need to differentiate it twice and then put the value of minus 2. So once you are going to differentiate it, let us do that. So first time when you are differentiating, you will be getting z plus 1 . The first time when you will be differentiating, you will be getting half d by dz of z plus 1 minus, there will be a minus sign, right? Z plus 1 will be here, and this side when you are doing, then z minus 1 divided by z plus 1 whole square. Now this will be half, z minus z gets cancelled, plus 1, 2. So this is 2. Take it out, this 2. And then you have d by dz of 1 by z plus 1 whole square. So one time more you need to differentiate this part. So finally, I'm writing the answer for A. This is z plus 1 minus z minus 1, z plus 1 whole square. Now, again, you need to differentiate it once more. So what you will be getting is 2 by minus 4 by z plus 1 cube. Minus 4 by z plus 1 cube. So there will be a half and there will be minus 4. So that 2, if you are not cancelling, in that case, there will be a minus 4. Minus 4 divided by z plus 1 cube. So here I am not cancelling this 2. So give me a second. This 2 I am not cancelling over here. Okay. So this is over here half and this one was 2. Now this is making it this at z is equals to minus what? At which point? Minus 2. So final value of A is coming to be 2. Okay. Now when we are going to calculate B, to see this very nicely, once I'll go up once more. So B is having this way. B was what? B for us was given as B by z plus 2 whole square. A was given as A by z plus 2. Okay. And B is given as z plus 2 whole square. Now what did I say? 1 by final multiplicity is, highest multiplicity is 3. Multiplicity over here is 2. In this case, the multiplicity was 1. So we did 3 minus 1. Now, differentiation. The order of differentiation will also be 3 minus 2. That is 1. D is z, 3 minus 2. And inside this, you will be writing the full function. That is z minus 1 divided by z plus 2 whole cube into z plus 2 whole cube divided by z plus 1. Fine. Now this is calculated at z is equals to minus 2. Fine. Now what we will be getting is b is equals to this. You have to differentiate just single time. So what you will be getting is 2 by z plus 1 whole square. 2 by z plus 1 whole square. And then when you put the value, the value of b is going to be 2. When you are calculating C, that time 3 minus 3, 1 by 3 minus 3. Okay. And then we will be doing d of 3 minus 3 and dz of 3 minus 3. Same thing we are going to do. And then again, z minus 2 whole cube into z minus 1 divided by z plus 2 whole cube into z plus 1, calculating it at z is equals to minus 2. So in this case, 3 minus 3 is 0. So that means you are not doing any differentiation and this value is going to be 1. So finally, what you are going to do is z minus 1 by z plus 1 at z is equals to minus 2. So the value of C you are going to get as minus 2. This 3. Minus 2 minus 1 minus 3 and minus 2 plus 1, that is minus 1. So that is positive 3. And d value already we have got it. Now we will write the full function same way, that is xz by z. We will write it xz by z is equal to a by z plus 2. It was there. So now my a is minus 2 by z plus 2. B is 2 by z plus 2 whole square. C is 3 by z plus 2 whole cube. And D is minus 2 again. D is minus 2 by z plus 1. Now this z over here, we will make it come over this side. And then we will do the same thing, dividing numerator and denominator by z or powers of z as it is there. Now let us see what happens. So in this one, you will be getting the first one minus 2. We are dividing by z in the first one. Fine. So z by z. So what you will be getting over here? 1 plus 2 z inverse. So I'll just remove this portion. Okay. So first one that you get is minus 2z by z plus 2. If you divide it, then you're going to get minus 2 by 1 plus 2z inverse. Right? Now the next one. The next one is plus 2. Here you see, since here final highest power of z will be square, so we are going to divide by z square. So 2 z to the power minus 1 will come here, and this one will be 1 plus 2 z inverse whole square. Same way here, we will divide by z cube. Then this is going to come 3z to the power minus 2 divided by 1 plus 2 z to the power, how much? Minus 1, right? 1 plus 2z to the power minus 1 whole cube. And in this case, we have minus 2 divided by 1 plus z inverse. Now again, we are going to do what? Inspection method. Inspection means you are comparing with the popular Z transforms. Now see, first of all, everywhere there is a plus sign, right? Everywhere there is a plus sign. So these are the Z transform for minus 2 to the power n. Now, the second thing that you have to understand is that since if you take this as, if you take the Z transform of 1 by 1 minus half Z inverse, that we have seen, the Z transform was what? Half to the power n un. Now here you see there is no Z. Fine. There is a Z inverse over here only. So just this one is just to make you understand. Now what will happen is that there is a 2Z inverse. First of all, that is a minus thing over there that you have to understand. Minus 2 to the power n un will be there. And then actually what we have done is we have differentiated it. That is why we are getting some powers over there, right? So the first one is almost simple. The first one will be simply written. That is, first one is for us minus 2 to the power n u of n. Getting it? Minus 2 to the power n u of n. So the value of a is minus 2. Let us check over here. Things are going correct or not. Okay, the value of a is 2. So here we will put a plus 2. This was by mistake over here. So this will be plus 2. So this is the first thing. And the second thing, again, it is 2. Now just be very careful. Minus 2 to the power. Okay. So now here the square is there. That means it has been differentiated one time. So you have to multiply it with n in the discrete time domain. Got it? So minus 2 to the power n un has been multiplied just differentiated just single time. That is why there is a square over here. Getting the point? Now there is one more important thing, that there is a z to the power minus 1 over here. Now this z to the power minus 1, why is it over here? And how we are going to compensate? So in order to compensate this, what we need to do is this is a shifting, time shifting. So here also we need to shift it in the time domain. So what we are getting is minus 2 to the power n minus 1. So if I rewrite this part, just be very careful while doing this part. So for this portion, simply this, you had this portion. But since there is a square, that means it has been differentiated once. So we are multiplying it with n. We know differentiation in z domain results in the multiplication by n in the time domain. So it is minus 2 to the power n minus 1 un. Why n minus 1? Because over here, you have multiplied it with z to the power minus 1. That means it has been shifted in the time domain by 1 unit. Now you can very easily write this part. Now this is 3. First you wrote the amplitude. Now see, it has been differentiated 2 times. So when it is getting differentiated 2 times, that means n into n minus 1. And then again you have minus 2. Now this is shifted also twice. So n minus 2 u of n. Fine. Now final one is easier. So I'll remove this plus. There is a minus 2 minus 1 to the power n un. Right. So here what we are going to get is minus 1 to the power n un. So this is all about this. Like this is the xn. This is my xn. Just once again I will tell how it has come. So this, if you see this one, there is a plus over here. In standard places, when you are having over here positive 2, or here you having positive 2, there should be a minus. So this we will put a minus 2 to the power n un. This term, this coefficient, or you can say this constant, is always acting as a coefficient over here. Now this 2 we rotate over here, and minus 2 to the power n un. Now next part is, here the same thing is there, but this is square. That means it has been differentiated once. So we are multiplying in the time domain by n. But there is z to the power minus 1 also over here. So we have time shifted it once. Same way here, we have differentiated it twice. So we have multiplied it with n into n minus 1. And this is minus 2 to the power n minus 2, because it has been multiplied with z to the power of minus 2. Now for your understanding, let us see some of the partial fractions. So if, this is a very important thing. If the question, if the fraction is z by z minus a, in that case, the signal will be what? A to the power n un, right? Everyone very familiar with this one. Now the next one, if the signal is z by z minus a whole square, that time when you take the inverse Z transform, it is going to be n into a to the power n minus 1 un. Now next one, when you are taking z by z minus a whole cube, then it is going to be n into n minus 1 divided by factorial 2 a to the power n minus 2 un. The same way it is going to go on. So by this, we can see that there is a small mistake over here. There will be a divided by 2 also, right? So this a is my minus 2 for this case, right? If you write it in with the simpler form, then a is your minus 2. And the same way it's going on. This you have to understand. Okay, thank you everyone. So we have done 2 types of problems, simple poles and multiple poles, poles with multiplicity greater than 1. For partial fraction, we did 2 questions. Practice these questions. Partial fraction is a bit It requires practicing. So be very careful about this. And the questions come from this part. Thank you, everyone. Let's meet in the next class where we will be doing the residue method.